Okay. Good evening, everybody. Can you hear me loud and clear?
Good evening, Prof. Yes, we can hear you.
Yes, it's raining heavily here, so there will be a lot of noise at the background, but I believe we can manage it. Okay. Okay, so first of all, I want to take this opportunity to thank all of you for coming. I can see only a handful of students, not more than 10 or so. I don't know where the others are. The class. Listen, I beg you. Okay, so I'm sure we can start, even though not everybody is here at the moment. Can you see the slide I'm sharing with you?
Yes, Prof.
The rain here is so heavy that there is light off, and I have to connect to my power bank. And I don't know, is it raining at your end as well?
About
No,
raining.
please.
Okay. I'm trying to see where I can hide to be able to deliver this class very well because the noise here is just too much. Okay, let me try and settle somewhere where the noise would be better.
Okay.
Okay, so now, okay, I'm sure you are now with me, and I'm coming to take you through the course outline. Can you view the course outline I'm sharing with you?
Yes, Prof.
Okay. So as you can see the course outline over here, and I'm meeting you for the first time, it will have been appropriate to meet face to face to introduce ourselves. But nevertheless, pretty soon, in a few weeks' time, we'll be meeting face to face and deliver the lectures. But in the meantime, this is the course outline that we are coming to follow. You can see the course title, and we have advanced database systems. And this is the master's level advanced database systems. A 3 credit course, 3 credit hour course, and we have prerequisite meal. So this is my name over here, Professor Winfred Yaokumah. I'll be running this course together with Dr. Edward Dansu. Professor Dr. Edward Dansu will be teaching the Sunday group, so to speak. We are following the same syllabus. There will be the same exam, the same marking scheme, and everything the same. So my email address is here, as you can see. You will need this email address for some of our communications. Okay. Now let me just find out. Can you hear me loud and clear? There seems to be a lot of noise here because of a very heavy rain over here. Can you hear me loud and clear?
Yes, Prof. We can hear you.
What is the extent of the noise? Can you hear the noise as well?
No, it's not that bad. I think your voice is audible enough.
Okay, that's fine. Okay. Okay, so first of all, we want to go through the course objectives. There are two things you need to identify in the course objectives. First of all, you see survey of research landscape, which is critical for you to take note of. So we will survey the research landscape of advanced database management systems with the view of understanding how database research responds to challenges arising from software architectures. Then two, the course will also focus on practical hands-on topics in database systems. So immediately you read the course objectives, two things come to mind. The first one is you will survey research within advanced database systems. And two, there will be practical hands-on experience of advanced database systems. So once we have these two objectives, and our course outline will focus on them. Now, the course would now pay particular attention to these important topics. We will deal with database architectures, and components, data models, databases, languages, query processing, query optimization, parallel database systems, distributed database systems, transaction management, concurrency management, and of course, data warehousing. So you will see that from here going, when you look at the beginning, there seems to be things that you might have known to some extent if you have done computing related courses at your undergraduate level. But when you begin to look at this topic, query processing, query optimization, parallel databases, distributed databases, transaction management, concurrency, and data warehousing, they form mainly advanced topics in database systems. Okay. So at the end of the semester, it is expected that each student will be able to model data with relational modeling, understand and master query processing and optimization, work with parallel and distributed database systems, familiarize himself or herself with new database architectures and query operators, master transaction processing, concurrency controls, cloud-based databases, and data warehouse modeling. Okay. So at the end of the period, it is expected that students will be able to do the following, or understand or know, familiarize themselves with the following, which are listed here. Now, how will the course be delivered? Basically through lectures, group discussions, and project presentations. So it means that you will be presenting some work, some group work in class. So there will be a group work that you are coming to do, which will be presented in class. There will be lectures, etc. Plagiarism, you are all aware of the seriousness of plagiarism in our department. So try as much as possible to avoid plagiarism. Certain guidelines here about the university's policy on plagiarism is listed here for you to take a look at. Now we have the assessment and grading. This is how the assessment and grading will be like. 50% for exams. Then the 10 paper you will be 25%. Then project will be 25%. Project is supposed to be, the project work is surely going to be group project. The 10 paper will be individual. Okay. And the exam will also form 50%, making your 100%. So that's how the grading will be like. Now there will be a lot of materials that will be used. Some are basically the key reading materials, whilst others are supplementary. So the first key material will be this. Cannoli and Beck, database systems, a practical guide to design, implementation, and management. So you will see that we'll be doing a lot of discussions from this textbook, which is very easy to read and understand. All right, there are others that we will make reference to, and there are other places that I will ask you to find some materials to work on theoretical concepts, bearing in mind that when we come from the beginning, this particular course will be focusing on aspects of research as well as mastering and practical hands-on experience. So we have two aspects. You can see that two aspects also fall into assignments and a continuous assessments that you will do. Because the course will focus on practical aspects, you'll be doing practical projects, which will take 25 marks. You would, of course, also be doing some research in an area of advanced database systems, which will be individual 10 paper. We believe that at the master's level, one should be able to put his hands to some aspects of databases and be able to develop something or something significant using modern and popularly used databases. We also believe that at master's level, students should be able to carry out some bit of research in the area of databases and write a short paper on a particular topic, so that you end up understanding that topic theoretically even better and deeper than the exam. The exam would focus more on practical aspects of database, not generally theoretical, mainly practical understanding of databases. Okay. So on a weekly basis, these are the things that we'll be covering. The first, database environment, relational algebra, lecture 2, and relational calculus. Then we will come to some of the things that you already know. Data manipulation language, data definition language, transaction control language, and the rest. I think data control language. So this, in fact, some of these topics might have been covered whilst you were doing your undergraduate. Those who have done areas in computing at an undergraduate level. Nevertheless, if you haven't done anything in databases before, this course for the first 3 lectures from 1, 2, 3, all the fundamental issues about databases will be covered. This is to ensure that we put you up to the level where you can understand the advanced topics. So the first 1, 2, 3 lectures will be discussing fundamental issues. So there is no call for worry if you haven't done databases or you never understood databases before. In this class, you understand databases. Okay. Now, from lecture 6, lecture 4, 5, 6 going, we'll be delving into more advanced topics. Most of you also have been familiar with stored procedures and triggers, transactions, then query optimization, parallel databases, concurrency controls, replication and mobile databases. There will be a presentation of the group project that we will be doing over here, the group project Each group will present its work for grading. Then we will talk about data warehousing. Then the data warehousing will take us at least 2 meetings. So that is the course outline. Maybe I can pause here for a while and take some of your questions, worries, even fears. If you are scared of something and you want to clarify doubts, I can take some questions at this point before we continue. So if you have any question, please do ask me. My classes are quite interactive. Not quite, but generally very interactive. So I expect that we will share ideas together, because in the first place, some of you have been using databases, working with databases and so forth. So when we share knowledge, you may end up helping some other students. I will also advise that you form study groups. You see, technical subjects of this nature is not advisable that you hide alone and keep reading it and on your own. It doesn't help. But form study groups, or the groups that you are creating, make sure you study together an aspect of the concept you understand, but the other colleague may not understand that. The other colleague may also understand something you also don't understand. Or some people understand this concept very well. They can help their colleagues as you do group work and you study in a group. It's easier that way. It's easier that way. So if you have any question for me or clarification from the course outline that I have shared, or generally you want to know something about the course apart from what I have talked about so far, feel free and ask. So I'll leave the floor open for a while. Is anybody having a question, a comment, a suggestion? It doesn't look like anybody is having any question to ask. Okay.
Hello, please, Prof.
Yes.
Erasmus speaking.
Yeah, Erasmus, go ahead.
Please, almost 90% of all of us, we are in the car now. So, because we went to
You
the
are where?
campus for yeah, we are in the car now going home because we went to the campus for the wireless principle of wireless course. So yeah, we are now going home. So it will be difficult for us to talk. As soon as we reach home, we join proper, we can participate more.
Okay. But at least you are listening to what is going on.
Oh yeah, we are listening. No, I just decided to talk because the way we are quiet, you think that we are not following you. We are following you, but we don't want to talk. Me, I just take the courage and talk on the church room. You understand? So,
I understand.
yeah. So
Most of you are not, most of you are not settled down.
yes, we are following him, but we cannot talk.
Okay, all right. So let's we can be moving on. We can be moving on. Okay, so after looking at the course outline, the next thing that we will be looking at will be to start the lectures, today's lectures. So today's lectures would go over some very basic concepts in databases, particularly some terminologies. The fact that we don't want to leave anybody behind, and the requirement to our computer science also did not specifically state that everybody should be from strictly core computer science backgrounds. There are some students who may not be familiar with databases. So what we normally do is the first few classes, we try to bring them up to the level we can move on with the advanced topics. So I'll introduce the textbook. We also have a lot of slides that are based on the textbook that I'll be making available to you. All right, so in the next few minutes, I will show the textbook and also make it available to the class rep. I will also need to know the class rep since we are meeting for the first time. Okay. So as you can see, just a minute, let me find the okay, let me find out whether you are able to view the textbook that I put up over here. Can you view it from your end?
Yes, Prof, we can view it.
So that is this book is going to be read as a Bible, at least for those who are used to reading Bible. The concept is we read Bible every day, and therefore this book is going to be read. Not all the chapters in it anyway. The selected chapters are supposed to be read. Even though there are a number of slides that I'll give you, I would most of the time be directing you to the textbook and also walk through the textbook with you, explaining some concepts. Well, so you can see Thomas Connolly and Caroline Beck, Database Systems, Practical Approach to Design, Implementation, and Management. So when you go through the textbook, in fact, it's very easy reading, even without my help. And you pick this textbook, you should be able to read it and understand it. This book would help you to fully understand or get in-depth knowledge in databases. Now, there are quite a number of chapters here. We will be picking some of them. For instance, as you can see on the course outline, we will see the introduction database environment. So these two, 1 and 2, relational models, relational algebra, then these are data manipulation, data definition, and so on. So 1, 2, 3, 4, 5, 6. That one. These are all forming the fundamentals. These are the things that normally are done at the undergraduate level. These are fundamentals. Now, we will also come and talk about normalization, entity relationship model, and normalization. We will not treat all the topics here, but 11 and 13 would surely be treated. Then you see where we have a transaction management and query processing and query optimization will be treated. You also on the course outline distributed database systems. So this will also be, and data replication will also be treated. Then some aspects of this, not all the topics here, but at least the concept, data warehousing concept and data warehousing design will also be treated. I think that will bring us to the end of the course within the next 3 months or so. This course is very interesting. Those who took it in the past found it very useful. Some even get back to me a year or 2 after they've completed that. It is helping them because most of you are practical men, and in whatever you do, you will come across databases. Even networking, you will come across databases because you will need to store data. In whichever area of computing, you interact with databases in one way or the other. If you are a programmer, you need databases. Networking, you need databases. Artificial intelligence, you need databases. Machine learning, you need even that one, even more data, where you need to be working with data sets. So this course is extremely important to master's degree programs that you are offering. So what am I trying to say? You will need to read this book. I have slides covering all PowerPoint slides covering all the topics that will be treated, which I'll give to you. But there are points, some of the points, PowerPoint's one disadvantage about it is if you don't grab the material very well and you only read the points, some of them will not be very clear. But when you read the textbook, which many of us don't read anyway, because generally we don't like reading. But if you want to understand the concepts and understand it very well, reading from the textbook as well as the PowerPoint are all very important. Okay, having said so, I'll be diving into the beginning. Today's class would be defining terminologies and having to remind you of databases if you have forgotten the concept that you learned some time back, or even if you haven't learned it before, no problem. That's why we are starting from the beginning. There is an interesting Chinese proverb that says that anytime you want to start something, you should start from the beginning. It sounds like tautology, when you are starting something, we expect that you are starting from the beginning, but people can start something from the middle, but not the beginning. The proverb says, anytime you are starting something, start from the beginning. And there is another saying that if you want to understand or you want to become expert in a subject area, make sure that you understand the basic concepts or get the basic skills, the basic concepts about that subject area. Don't jump to the end of it whilst you don't understand the basic concepts. I will tell you something. When some students were presenting their research, and they make use of a number of basic concepts in their work, which in actual fact they don't understand. So during the presentation, we ask you basic question, basic, very fundamental concepts of what you have done. They weren't able to explain those fundamental concepts, which they assume that they have known and understood. They could not explain them. So it's very important if you want to develop a skill, make sure you understand the basic concepts within that subject area. So we are yet to go now, starting from the chapter 1. Something from the chapter 1. But I will still, having understood that some of you are on the move, I will still pause for a while. Maybe somebody may want to ask a question before we get started. In my class, I make room for questions, comments, suggestions. Maybe you want to bring some dimension or you want to explain some insight or bring about some kind of understanding to a concept, or you want to demonstrate or illustrate a certain concept or further explain a principle. Why not? This master's class, we can discuss. Sometimes during such discussions, the students actually understand what is being taught. So I always open the floor for questions, and even I open floors for criticism if there is need for it. So if there is anything as such, otherwise I will now again move on. All right. The class has been very quiet. I hope you are still with me.
Yes, Prof, we are here.
Erasmus, are you with me? Erasmus said he is driving. And I'm sure many more people are also driving. Daniela, are you with me or you are also driving?
Hello, please, I'm here.
And you are quiet. Daniela, I'm sure you are doing well.
By God's grace.
Okay, we thank God. We thank God. Okay. Generally, anytime I'm teaching this program or I'm teaching a course, I always want to know students' background in that course. So what I do is I ask each student whether they have done anything in databases or in the area of the course that I'm teaching. Then it gives me the idea as to how to teach the course, which examples to give to demonstrate or illustrate the key concepts that will come across Now, I just want to ask a general question since I cannot go around everybody. Is there anybody in this class right now that has never done anything relating to databases? If you are here like that, don't worry at all. Don't feel like you don't know anything. Generally, those who come with nothing in their hands, they end up getting better marks than those who come thinking that they have something in their hands. Because those who come with nothing, they know they don't come with anything, so they concentrate. Those who come with something, they say, I know all these things, I know them all. And they don't pay attention. If you are here and you haven't done anything relating to database, just let me know. Is anybody like that? Yes. I think somebody wants to. Pardon?
Hello, Prof.
Is there anybody like that?
Yes, please, Prof.
Okay, that's good. That's good. So it is a good idea that my first 3 classes I would concentrate on the fundamentals. Something happened recently that I just feel that I should tell you, or to buttress the fact that you should form study groups. You see, last semester when I was teaching a course, I was teaching both MPhil and MSc. So I advised the class that they should form study groups. Because what I was teaching, there were a lot of difficult concepts to understand, but I managed to explain them seriously. It was difficult concepts, and I told the class that they should form study groups so that they learn together. It appears to me that the MSc students form study groups, even though I'm yet to verify. When I was marking their script, I noticed that some of the questions that I set, and I was thinking that there will be maybe topics that students may not want to attempt or answer those ones. The MSc students were able to answer those questions correctly. And when you take a look at the answers they provided, you will begin to feel that they have learned together. They have learned together. Unfortunately, the MPhil students, it appears to me that they did not form a study group, or probably I can't tell, but the way the answers that they have provided was far worse than the MSc students. I'm saying this because in each of the areas of your study or each of the courses you study, form study groups. You are all not at one place, but you can meet on Zoom and somebody will understand the concept and be explaining it to others, and the others will be asking questions and others will be making contributions. It makes life very easy because most of you are working and may not be able to devote all the time to face it all alone. So bear that in mind. Okay, having said so, let me go back to my course outline. Okay, so this is the very first thing we want to look at, fundamental concepts. We ourselves, so students coming to this program should not necessarily have strong IT background. And therefore, when we come, we should start from the fundamentals. So chapter 1, introduction to databases. So these are the things that we are coming to look at over here, the objectives of this chapter. The common uses of databases systems. This one like that, if I ask you, you can all say it. The common uses. The characteristics of file-based systems. problems with file-based systems. Then the meaning of database. Of course, sometimes when you want to frustrate people and they come for an interview and the person did very well in databases, maybe on the person's transcript, then you ask fundamental question. Can you explain to us what is meant by database? That's basic question. Then you say that way the person will struggle. So you will need to get these things at your fingertips, what they mean. What is the difference between a database and database management system? You need to know. What are the typical functions of database management systems? What are the components or major components of database management system environment? What personnel are involved when we are dealing in database management system environment? Then some history of how database management systems were developed. Then advantages and disadvantages of database management systems. These are the things we are coming to learn in this chapter. I will also advise you that anytime something is taught in class, don't put it aside for several weeks when exams or some test is going to be conducted and you're going to take it and you start reading. You will save yourself a lot of energy and time. If something is taught here in class and within the next 24 or 48 hours, at least you find some time to glance through. It takes faster than you leave it. And then some weeks later or a week or two later, you take it, you struggle a little, waste much more time. Now, finding some time within 24 to 48 hours, to even 15 minutes or 30 grams through, it takes faster. Okay, so now let's start from, I'm just taking, I have this material as PowerPoint, but I decided to just take you through the textbook and show you some of this. There are many times I will use the slides, but sometimes also look at it from here. Okay. When we talk about databases, I want to believe that in our world today, as we use digital devices, in every day, each of us intentionally or unintentionally creates some data. And this data is stored somewhere or kept somewhere in some storage. And therefore, we cannot live. We cannot live. I believe we cannot live or we cannot let a day pass without having some data that we have generated that are stored somewhere. How are they stored? Many do not care about it. But we as technologists, we need to know because we are creating environments where the data should be stored. Efficient ways to manage the data and so forth. So we have a lot of databases or systems that allow us to be able to capture or define, capture, create, and so forth, and store and retrieve data. And many applications have been developed that utilizes databases. So we just want to mention some applications. I am even trying to wonder whether there is any application that do not store data. In any case, even the application doesn't store the data on disk, which I even doubt if there are some. At least they store the data temporarily in memory, manipulate it, and maybe later on discard it. But every application keeps some data as to how they are kept, either on flat file or in a database, or whichever way. They all store some data. Major industries or business environment has made use of databases a lot. So you will see even supermarkets, they use databases. Even credit cards that you transact, to withdraw money and then pay for transactions, database. Even booking, database. Even when I create Google form database. If I use libraries database, that's behind. Insurance, banking, even video rentals database. Even if I use internet, the data that we are moving around to your emails and then social media, all of them behind the scene database. If I apply to university and my records are kept, database, still database. So when you begin to think through, you see that every application now is about database. If I pay utility bill, it's database, I'm storing it and manage it for efficient retrieval and record keeping. So you see the importance of database everywhere. Everywhere. It's everyday usage. Okay, having said so, when we begin to list areas where we use databases, we may list more than 1 million applications where we use databases. As I said, I even wonder whether there is any application that doesn't store any data. At least, if we discard the data, at least when it is processing it, it stores the data in memory. Payroll, and so forth. Okay. Having said so, we want to talk a bit about the databases, how they came about, how they started, what concepts were used at the initial stages of creating and managing databases. You know, when somebody tells you today that when computers were not there, we did not have databases, the person deceives you. We had databases, even the time that computers were not there, but we did not have them digitally. So what we were using in the offices at that time was to take a flat file. So we can name some of them personnel file or job description file or so forth on the flat file. We put the name on it. Then inside we put the records, some kind of data written on paper, and we file them on it. So we keep doing that. Then we create a cabinet. Some of them are even fireproof. Then you put all of them in there, then you lock it. Those that are not critical, you put them into some shelves or even on tables and whatever. Anytime you need or to update that file, you go for it. That's a retrieval. You look for the name, search through, find it, do an update, put it back into the cabinet, into the flat file, put it back into the cabinet. That's how databases were managed during those days. But later on, the computer guys like yourselves realized that once computers are available, we could automate that system. The system of putting a flat file, dump it somewhere, go back for it, and so forth. That system is still being practiced today. And some organizations still believe that the source data is still important. So we still file them, put them into some cabinets some way. All right. So when the IT databases started coming up, the technologists started thinking through how they can use computing systems to manage the original traditional file systems that they were using. So they developed a system, and in actual fact, they named it after the manual ones that they were using, the file-based systems. In some textbooks, you will see conventional file systems. The here we say traditional file-based. It's traditional because we took it from the original and the normal manual ways that we were filing documents and retrieving them. So this system, the IT systems that were developed at that time, kept data in a flat file. Maybe I need to explain a flat file or give an example to explain how a flat file is. An example of a flat file can be the notepad content. I'm sure all of you have seen the contents of a notepad or notepad plus plus or a text editor, the way they store data. So you see sometimes when you open a notepad, you see a lot of data on it, and sometimes it looks to be garbage separated by some delimiters and so forth. So when these database systems came up, and there were not relational databases at the time, we were using flat files to store the data. So let's say you develop an application. When you save the data, you go and save it on the flat file, a file where you can open it even in Notepad. And then you see one record will start end somewhere with a delimiter, which may be maybe a semicolon. Another one will start. So when you read, you see that everything is like jumped. So that's the way the flat file systems. Somewhere in the year 2000, I worked with one of the major banks, and we were using flat file system. And the application name of the application we were using is called Bank Master. So when the tellers at the front end post a transaction, it will save it into a flat file, which is basically a notepad. So we can open that notepad, then you will see credit, so, debit, so, with certain amounts. Then a delimiter will come like semicolon. Then another one, debit, that credit, John Baba, this. So you see that the database is now the flat file, not a relational database. So you can imagine, even the year 2000, a major bank was using that. Of course, now they have moved to a more robust relational database management system. So that's how the flat file is. But then let me just define a flat file, and I will show you something in there. This file-based system is being defined as a collection of application programs that perform services for the end user, such as the production of reports. Each program defines and manages its own data. This is the key thing here. In the flat file system, each program defines and manages its own data. I will let you look at the diagram and I will explain it. So now, what it means is, if we are developing in a particular organization, we want to develop an application program. One of them is maybe payroll. The other one is stock management. Let's say the other one is asset management. The other one is sales management, and then so forth. We would create a database which is in the form of a flat file. Then we can develop an interfaces. Those days we're even using Fortran, COBOL, Pascal, those programming languages. When we develop the interfaces with appropriate buttons, now the database, which is in the form of flat file, is linked to that application software. So we can develop one, let's say payroll, and link you to the payroll file. Then we can also have another one, stock management, link that the set of applications that we have, the link it directly to the database. So the two databases do not communicate. Maybe this diagram will help us to appreciate what I'm trying to explain. You see this diagram? This is the diagram. So look at the way it works. We have a database here, sales files, contract files. Then we developed some application, maybe using C++ or C or Pascal or COBOL or Fortran, which is here. So users, when they use it, the data is saved. The data is saved on sales database or sales files. Then they can retrieve from there. So when we have another system, let's say we have a contract system. Contract files are here. A set of programs are developed. The users use it, they save into it, they retrieve from it. When you look at this very carefully, you see that these two databases are completely independent. It's independent of this. Because this kind of architecture at the time posed a number of problems. To the users. So anytime we want to develop a new application, we create its own file, which is independent, cannot communicate with each other. So that is the architecture of the flat file system. A number of issues were encountered with this architecture, which led to development of relational database systems. Okay. Now, what are the issues? I'll mention the issues that were encountered. Then after that, I will pause for any kind of questions that you want to pose. So these are the limitations. The isolation of data, separation of data. And look at this. If somebody in the sales department wants some information about what has happened, maybe something about contracts, you will not have access because the databases are completely independent, separated. So sales department will only get information from. Meanwhile, somebody in sales department may need some information from contracts, and it's not possible. Similarly, contracts may need, it's not possible. So it's one of the challenges. Another challenge is duplication of data. Certain information over here on this database may also appear in this database. For instance, if we have an application where we have payroll, and then we also have maybe this example is not too good way to explain it. Maybe payroll, and then we have here general records of an employee. The payroll contain employee's name as well as general records of the employee which is here. So you will end up duplicating people's names. For instance, this database will contain some information that will be the same here. So why do we need to duplicate records or some data? So that is where we have, because we need that data here as well, we need it here, we will need to have it twice instead of having it once if we were to integrate these two databases. That is another problem. There are quite a number of other problems like data dependency. The programs are linked directly to the data. So programs coded over here are linked directly to this data. You see? So anytime we want to retrieve something, we have to link it directly to the data here. But we want a situation where the data is independent and any of the routines can access data across the databases. So we also have incompatible file formats, then fixed queries and so forth. Another one is even security was at stake because you keep duplicating data or the confidentiality issues are at stake. We cannot actually provide stringent security on the data that are separated across various machines and various databases and so forth. So these are some of the issues that we encountered with this initial architecture that we were using 1960s down to even 2000, the year 2000 and so forth. We're still using this kind of architecture. Okay, I would pause here for a moment. Should you have any question? As I said, these are all fundamental issues that we are looking at today. If you have any question or comments, you can pose it before we continue. Okay. All right. Now, so far as we don't have any questions, I can safely assume that so far so good. Then, when these issues or challenges were identified with traditional file systems, databases, the relational databases were developed to solve those or to offset those problems. So we now come to define database, relational databases. I told you today there will be a lot of definition of terms. So now database. The database is a shared collection of logically related data. Its descriptions of the data, that's metadata. The data, logically related data, is metadata designed to meet the information needs of the organization. So that is a database. Okay. Now, the metadata or the description of the data, we normally can say that something describing. So when you go into databases, you will see the database, which is the shared logical related data plus data describing this data. That's the metadata. That's metadata, which are normally sometimes referred to as data dictionary, or which are stored in systems catalog. Okay, now let us again look at, since we talk about databases, we can take a look at database management systems. It's easy to understand this because we talk about database. So now it's a management system that has added. So now it is a software that enables users to do what? Define, create, maintain, and control access to the database. So when the database itself is made up of logically related data with its metadata, which stands on its own, how do we manage it? We will need a software. In that software, quite a number of them are there. We'll be mentioning them pretty soon. Database management system, which is a software now, allows us to define, create, maintain, and control access to the database. So that is database management systems. I expect that if somebody asks you to distinguish between the database and the database management systems, you should be able to give a clear distinction from today onwards. Okay, so now within the database management systems, we have a lot of program models that are developed. Some can define, others can create, others can maintain, others can control access to the database. We normally classify them into 4 different categories, which you saw me typing into the course outline earlier, where you saw me writing data manipulation language, data definition language, for instance, we want to create. Then we have a transaction control language. Then we also have data control language, which are used to define access, privileges, and so forth to the database. So these 4 languages that I've just mentioned, data manipulation, data definition, transaction control, and data control languages, are embedded into database management systems that enable us to interact and work with the database. So you can read about them over. You see the data definition language, data manipulation language, and so forth. These languages are put into a certain format, which we refer to as SQL. Some even SQL. We normally sometimes we say SQL. Sometimes we say SQL, whichever way is the same, which means structured query language. It's a language that we'll be looking at as to how it is written. We'll see the fundamental principles behind it. It's very important to know the language, otherwise we wouldn't understand query optimization. So we'll go through some of the languages that some of you are even already familiar with, but perhaps we will see more advanced queries. Okay. So now we have defined database and database management systems. I would again pause here for a moment and if there are some questions you may ask before we continue. Okay, so now that you don't have any question, now I'm going to ask a question. And if you don't want out to answer the question, I would call you and answer it. I have just mentioned 4 languages that are embedded into database management systems. What are they? What are the 4 languages or programming models that are integrated into database management systems? Anybody? If you don't want out, I'm simply going to mention your name. If I mention your name and you don't speak, I will assume that you only put on you only join the class, but you are actually not with the machine.
Hello, Prof. Can I mention one?
Yeah, mention one.
So the SQL.
Okay.
Hello, Prof.
Fine.
Can I also mention one?
Before you come, let's finish with Sakye.
Yes,
SQL
please.
is the general term that we have used to describe the language. So SQL is structured query language, and I want the 4 categories of, the categories of the language of the SQL. So the SQL is the master or the base name covering all the 4 that I just mentioned. So you are right to mention the big one first, which others fall under. There are 4 different categories that fall under the SQL. Okay, Daniela, I think you want to speak. Go ahead, mention one.
Sir, please, we're mentioning one of what?
We are mentioning one of the models of programming language, so structured languages that form part of database management systems. I mentioned them earlier, so I want to test your ability to remember or recollect what we said. Okay, maybe I'll give you one so that you can, maybe that will make you remember the rest. Data manipulation language is one of them. What are the others?
The data definition
Please,
language.
data definition language.
Okay, that's right. Okay, what are the other 2?
Data control language.
Data control language.
The data query language.
No, it's not query. It's data control language. Data control language. Okay, so these are generally the main 4 languages that are embedded within the SQL or database management systems that are used to create, define, manipulate, manage, control data in the databases. So you will see, if that is the case, then everything we'll be doing in this class will fall under one of these. Everything we'll do will fall under one of these. Okay. So you can start reading around and you see there are very interesting things that you can do with databases. And several people these days, because of a number of templates and how easy one can use some of these tools to develop systems easily, a number of students will not take the pain to understand the design of databases and so forth. When you are coming to develop large database systems, and you don't understand some of the concepts, and then you only use tools to quickly create screens and link them anyhow. If you are developing big systems and you don't understand and implement some of the efficient ways of designing databases, you see that your system will not perform well. Like you don't understand query optimization, you don't understand how do you call it? You don't know how to design relational systems or object-oriented database. You don't know any, and then you just use tools and then you pull data from the database, it shows on the screen, and you go. When the database begins to grow, then you begin to realize that your system will become very slow because you don't use query optimization techniques. You haven't even used how to use transaction management and so forth. Okay, so these four categories that we have mentioned are critically important, very critically important. But so far, you see that we talk about the database, which we defined here. Maybe I can test your knowledge about the database as well. What did we say is a database? I'm not talking about database management system. I'm talking about database. What did we say is a database? Anybody? Okay. I think I have to be calling people's names.
Can you hear me?
Yes.
Yes, we said a database is a shared collection of data, including its metadata. That's the description of the data that you are storing to meet organizational needs.
Okay. You are right. You are right. So that is you should know these things by heart. In fact, these simple definitions, if you understand them and we begin to treat advanced topics, you see that you don't have any problem at all. So now that's a database. So now we then come to the management system that manages the database. That is a software that can define, create, maintain, and control access to the database. This is where I told you that within this database management systems, we have data definition, data manipulation, transaction control, and data control languages. There are so many other models over there, but they all fall under this, like facilities, like what we call stored procedures, triggers, events, functions, and so forth. They are all embedded into these four categories of languages that we just mentioned. Okay. There is another thing that is of interest. The database and the database management systems alone are not enough to get somebody working and interacting with the computers, because we need to provide even interfaces where users can interact. We need to provide business logic where computations can be done, and so forth. So the third aspect of it is the application programs, which normally we write using application software like C++, C#, how do we call it, and many other languages, Visual Basic, and then all sorts of programming languages, hundreds of them that we write, PHP, ASP, JavaScript, all sorts of application programs that we write. So we have a computer program that interacts with the database. This is when we write application program, it interacts with the database by issuing appropriate requests. So within our application programs, we issue appropriate requests that links us to the database. Actually, it doesn't link us directly to the data. It links us through the database management systems to the database so that we can interact with the database. So interaction is from application programs through the database management systems to the database, and then vice versa. We can issue commands, fetch data, data wants to manipulate the data, alter the data, update it, save it back through the database management system to the database. So that is application programs, application computer programs, application programs. So this diagram explains this. The first diagram was the file system. But when you see this diagram, it has now provided us the better architecture than the file system. For the file system, we still have the sales and contract, but they are linked directly to different databases. But here we are linked to one database. So the contract files and the sales files are all stored on one database in the integrated manner. But in between them, we now put database management systems, which would facilitate interactions with the databases with all the languages that we just mentioned. So you will see that somebody at sales can now conveniently retrieve data from contracts because they are all in the same, integrated into the same database over here. Somebody from contract can likewise fetch data from here, while the database management systems facilitate that sort of interactions between the database and the application software over here. So that is the architecture of the database management systems. Okay, if you have any question on this, you can ask me before we quickly take you through the. I want to quickly take you through the advantages, which of course when you read you understand. It has its own advantage. There is advantages that we observed when we were talking about the file system are now solved. There are about 6 of them. 6 of the challenges with the flat file are now solved by the database management systems with this architecture. There is another architecture, but I will not talk about that one today. That's the data warehousing architecture. We have actually found problem with this one also. When we come to an era of big data, that this architecture has not been able to solve issues with big data. Those of you who work with databases will bear with me. That as the data begins to grow very big, this database begins to grow very big. Accessing the data is hampered. The performance degrades when the data here becomes big. When this now begins to contain millions of records, then problem. You issue queries, it takes a considerable amount of time to get results and so forth. So other architectures were developed, and one of them is the data warehousing schemas. Particularly when we just want to retrieve our non-necessary computations, then this architecture is not the best to use. Next week, I'll be talking about that architecture. I'll give you some background of that architecture before we come and treat data warehousing as a topic on its own. So you can glance through the advantages of the database management systems. Okay. And, we still have 15 minutes to go. In the next 10 minutes, I'll be taking you through some other aspects of this, because this chapter in 10 minutes we will be done with it. It's straightforward. These are the advantages and disadvantages of database management systems. As I told you, data now it eliminates this redundancy issue that we don't keep the same record on different databases and cause duplications. It also provides us data consistency. In fact, we summarize them all here. A lot of advantages that you can read. Data sharing becomes very easy because sales department can fetch data from contract department, payroll can fetch data from other accounting systems, and so forth. A lot of advantages listed over here. Okay. Having said so, they are all explained here. It also has disadvantages, of course, which are listed here. Complexity, even the size, the cost of the database itself, additional hardware cost, even cost of conversion data from one system to another. Some of us have been having challenges with these things a lot. When we move our applications or migrate our applications to new platforms, you see that some of the data formats will not be consistent. You will need to come and do a lot of, because some of your application commands queries will fail, not because the applications developed is wrong, but the database cannot save in a certain format which originally has been working on the old platform. So you see a lot of challenges. In performance, as I was telling you, the database grows, the system becomes very slow, and then so on. So these are the disadvantages. Each of them has been listed here and well explained over here for your information. I told you, if you want to understand anything, understand the basic concepts. So this is very chapter 1, basic concepts. So it's to be good that after this class, you go back and then you study all this, read through this on your own. It would really help you pretty soon. Now we have 10 minutes, 12 minutes to go. We are going to take a short break of 2 minutes. After 2 minutes, I want to get up just to stretch my legs. After 2 minutes, I will come back and we'll have 10 minutes to run off. I'll be talking about components of database management systems environments, which you already know. It is good for us to highlight it again. So 2 minutes, we'll be back to continue. Okay. All right. I hope you can hear me again loud and clear. Are you there?
Yes, Prof. Please, we can.
Okay. All right then.
Yes, please.
Okay. Now, let me just, since we have few minutes to go, let us decide that we want to talk about components of database management environment with this diagram together with the roles in database environment. At this stage, I do not want to rush the class. There is a time coming where we will speed up. But the first three classes, I'm really treading carefully, such that I would pull every one of you along. So I've decided not to talk about these two sections that are left in our chapter 1. When we meet next week, that's the first thing I will talk about. Within the 10 minutes or so, I'll be done, or 15 minutes with it. Then we'll go to the next topic. For that matter, I will leave the floor open for questions, comments, suggestions. If you still have any fear to express, you can express even fear or doubt, or you are not too sure how it's going to be like, and you want to ask some few questions. We'll leave the floor open within the next 5 minutes or so, then we can run off. I may also want to know who the class rep is, such that I can pass on the necessary materials to the class rep to be shared with you.
Prof, please, as it stands now, we've not selected a class rep yet.
Okay. So in the course of the week, when you have your class rep, just let me know, and I will make some information available to you.
Hello, Prof.
Okay. Yes.
Is it possible that you can pass through someone among us so that we can get the slides maybe tomorrow?
Can somebody, then one of you should send me your email address. Some of the materials are quite heavy, the textbooks and the slides. So what we can do is, Prince, I think Prince has raised a hand. Prince, you want to speak? Prince, you've raised your hand.
I was saying that you can come into the class.
I can.
Hello, Prof.
Yes.
Yes, I was saying that you can share the
Okay,
class for me to share to the class.
Okay, Prince has opted to collect the materials and share with the class. So by tomorrow, I will send the materials, the course outline, the slides, and things that you need for now to Prince so that he can share with you. I think that will be fine. Okay.
Okay, it's fine.
Prof, please, are we going to get
Yes.
the recorded class too?
Prince, you are recording it, isn't it?
Prince, Prof, I will make it available.
Yes, Prince is recording everything. Prince, I'll be introducing Prince later on. So is taking the recording and will make it available. So when you go to medical school, they don't allow recording of online classes. The reason why they don't allow it is once a student knows that there's going to be a recording, they don't show up. So maybe if that's going to be the situation here also, we may not be recording the class because so many students will not show up anymore. Sometimes you see only 12, about 15 students in your class. But in the exam, you see 80 students coming to write the exam. 80 students will come to write the exam. So I'll think through that one carefully and maybe follow the way medical school does it. Because so many will not show up. It's rather unfortunate. Rather unfortunate. Maybe I'll follow when I see the trend of events, then I will advise myself. Okay. If you don't have any more issues or matters to discuss, I hope you have learned something today. Some of you, all these things are not new. Some of you, they are not new, but at least it refreshes your mind. Some are hearing these things for the first time. Whichever category you belong to, I believe all of you has grabbed something from today's class. Our subsequent classes will be even more interesting as we delve into advanced databases. On this note, we'll end the class here today and see you next week. Bye.
Thank you, Prof.
Thanks.